Okay, good morning all of you. Uh, in this session of class 10 physics, we are going to now actually start the ray diagrams. The previous session I was telling you how we should go about doing the ray diagrams. Now in this session what we are going to do is that we are actually going to discuss the ray diagrams. So in one session it will be a bit difficult for us to discuss all the ray diagrams. So today I'll only focus on concave lens. So concave lens, the first ray diagram, if the object is at infinity, suppose the rays are coming from infinity, okay, so you can see that I have drawn two parallel rays, okay, so these are parallel rays, like the top one and bottom one, they are parallel to each other. So after they are passing through the lens, if you produce them back, they appear to be coming out of F2. That is very normal, that is what we expect. So basically, the object is at infinity and the image you can see is just reduced to a point. So the image is produced by the reverse meeting of the rays, so it is virtual. With respect to the object it is erect, but it is diminished to a point. So this is the first application of concave lens. Okay, now we come to case 2. The object is at infinity and the rays are oblique. Okay, so the object is at infinity from where the rays are coming and the rays are oblique. So these are the two rays. So they are oblique rays. Now the ray passing through optical center goes straight through, and you can see this ray is headed for the focus on the other side. It becomes parallel to principal axis. The reverse intersection of these rays will give the image A dash B dash at F2. So if the rays are if the object is at infinity and the rays are parallel, you will get virtual, erect, diminished to a point. If the object is at infinity and the rays are oblique, then you will get virtual, erect and diminished, not to a point. So this one will be virtual, erect and diminished. And where do we use this? We use it in a Galilean. We use it in a Galilean telescope. Okay. See, Galilean telescope is not in your syllabus, but many years ago, the famous, the iconic Galileo Galilei, the very famous scientist, he thought that the basic problem with any telescope is that it uses a convex lens and therefore it produces a inverted image. So he thought that why not use a concave lens. So he is the person who thought that we should use a concave lens in a telescope. Otherwise, so Galilean telescope would be a very good telescope for terrestrial observations. Okay, like a sailor wants to look at where the land is. He's in the sea and he wants to see where is the land. So Galilean telescope will be very good for that. So this is case 2. Okay, now we come to the third one. So first one, object at infinity. Second one, object at infinity oblique rays. Third one is, it is not at infinity, it is anywhere, but it is not at infinity. So we say finite distance. So suppose the object is here. So the ray parallel to principal axis is going like this, appearing to come out of F2. The ray through optical center is going like this. So the image is A dash B dash. It is virtual, erect and diminished. And this one we normally use it in spectacles. You have heard of the, it's very common actually, myopia. So short-sightedness. So those who have myopia, they need this particular lens, right? They need this particular lens for correction of myopia. So this is use number 3, right? So I am giving all of you one homework question, only one homework question. The question is that as an object, the question is for today's homework, there's only one question. The question is, as an object moves from infinity close to a concave lens, as an object moves from infinity close to a concave lens, how does the size and position of the image change? Okay, the question is, as an object moves towards a concave lens from infinity, it is moving towards the lens, but it is beginning from infinity. How does the position and size of the image change? Right? That is the question. This is the homework question. There's only one question, and you can submit it by 9 p.m. Tuesday. Okay? So we'll have next set of streams tomorrow. So you can submit this homework by 9 p.m. tomorrow. That will be all. I'll end the session now. Bye all of you.